We're going to do a quick video here on p-values and how to use our calculators to run these tests. So hopefully you watched the videos that I already had here back on 171 and 172. 172 just goes over how to run these tests and the background information. 171 goes over the central limit theorem, which is more of an HL content, but it's just going to this idea that we can use normal distribution rules to analyze a lot of different things, even if they're not normally distributed, if the sample size is large enough. For HL kids, the sample size large enough means greater than 30. That's an IB thing, but it's also sort of a general stats thing, okay? When we go to assess p-values, okay, p-values are how we're going to accept and reject our information. Are we going to say that they are significantly different or not significantly different? So you're going to get a p-value on your test, and that p-value means how likely is it that these two things are different just based on randomness, okay? So when we're going to jump down here to 176, and we're going to go ahead and do this test, okay? We're going to run this test using our calculators. So I'm going to clear all this out. Nope. And the way we're going to start this test is, because we have data, we are going to go ahead and use the data setting in our calculator. Use the data setting. So you're going to go down here to spreadsheets, and this is on slide 176 if you can't see the data very well. There it is. So we have group 1 and we have group 2, and we're going to enter our data. 54, 62, 67, 43, 85, 69, 73, 81, 47, 92, 55, 59, 68, 72. So that's group 1. Group 2, 73, 67, 58, 46, 91, 48, 82. Whoops. Oh no, I didn't actually switch columns. It's the worst. Watch this though. Where are we? 73. Y'all love this. Control X, Control V. Boom. So now you know how to fix a mistake. 81, 67, 74, 57, and 66. Okay, so we have our two data sets entered, and what we're going to do is we're going to go ahead and run a 2-sample t-test. That's going to be in our menu. Okay, all of these sample tests are going to be in the menu. Stats, we are running statistical tests, and we're going to be using this one a lot now. So statistical tests, we're doing a 2-sample t-test. 2-sample t-test. We have data. Okay. Our list 1 is group 1. Our list 2 is group 2. Now, it doesn't really matter which one you assign to list 1 and list 2 until you get down here to this alternative hypothesis component. Okay, so you need to make sure you know who is where when you're thinking about your alternative hypothesis later. So we want to know, are they different, right? So are they different means two-tailed. Okay, so are they different? Is mu1 not equal to mu2? Okay, so that looks good. Pooled should always be set to yes for IB. Come down here, click OK. So our p-value here is 81.6%. So that means that there is, I'm going to go ahead and add a page here. So we have 81%. 81 is greater than 5. So we would say that this is acceptable level of difference. Okay, and we're going to accept the null hypothesis, or you could say we reject the alternative hypothesis that they are significantly different. Okay, so that's how you would run that test. Okay. That would be the conclusion. All right, we're going to do one more. We're maybe not going to put all the data in here, but we're going to go ahead and look at this. So this test right here it says, are these two data sets different? We want to know, did the Atkins diet provide more weight loss than the other test? So are they significantly different? They're saying, does the experiment show that the Atkins diet leads to a loss in mass in a year? So mass loss is considered negative. Okay, so like this person lost 17 pounds, this person gained 17 pounds, right? That's what those positives and negatives here. So be careful when you're doing that. This one is also going to be a data entry test. We're not going to run the whole thing at this point. We're going to go Atkins, conventional, okay? And I'm only going to put in just like the first couple data points here. 17.3, 39.3, 26.5, yada, yada, yada. Then you would do the same thing over here, 11.7, 14.4, negative 7.2. Okay, so you would go ahead and put all that information in, and then you would go menu, stats, and we're still going to do statistical testing. We're still doing a 2-sample t-test. We're still using data. Okay, we would have Atkins versus conventional. And we want to know, did we lose more weight? Is the average weight loss greater for Atkins than conventional? So we need to pick this one right here. So because we have Atkins as list 1 and conventional as list 2, this needs to be our alternative hypothesis. Still running it as yes, and then we would click OK, and of course these aren't the real values because we don't have all the answers in here. But this is how you would run this test. You would make sure you had it done correctly here. Okay. This is an HL question. We can skip it for now. This goes over how to do it when you're having stats instead of data, so be careful for that. Two sample, and remember, she may not set hers to yes, that's sort of an IB thing, so make sure you have pooled always set to yes. Your practice is down here, HL only. I want you to skip this for the moment, even if you're HL. Practice 181, 182, 183, 184, and if you look right here on 181, there's the key for this assignment. So if you are not sure how to do these, check your work as you're going. Make sure you're doing them right. This is the homework for the weekend. When we go on to Z population testing, this is only HL. Please do not forget to pick up your M&Ms so we can start chi-square testing soon. Miss you all. Bye.